What do we say we get started, everybody? Well, welcome. Hello again. If this is your first webinar, allow me to introduce myself. My name is Jeff Martins. I am the Chief Operating Officer at Determinate Systems. I'm your host today, and I'm glad you're here. Today's webinar is going to be focused on seamless Nix deployments with FlakeHub. So whether you're a longtime Nix user or just getting started and trying to figure out how it fits into your organization, I promise you, you are in the right place. So real quick, a little bit more about Determinate Systems. We are the enterprise Nix company. We're dedicated to making Nix more secure, simple, and confident in enterprise environments. We build tools like Determinate Nix, the ever so popular Determinate Nix installer, which we're thankful that many of you here today use, and of course, FlakeHub, which is a product that we're going to feature today in our webinar. We also contribute upstream and across the Nix ecosystem. We're lucky to count two great longtime contributors to Nix, and the creator of Nix as one of our co-founders, Ilko Dolstra. But most importantly, we love Nix, and we are excited about helping organizations harness the full power of Nix, whether that's from software development, infrastructure management, or secure and reproducible builds. Whether those are using our products or not, we want to see Nix used more and more because we believe that it really is the transformational technology that many of you here today know that it is. Okay, so enough about me and Determinate. Let me introduce you to our speaker today. This is somebody that's one of the most knowledgeable Nix people that I know, and somebody that I'm lucky to work with, and also an all-around great human being, and that's Luke Perkins. So if you've been around the Nix community for a while, you've probably come across his work. He contributes to projects throughout the ecosystem, but also serves as an engineer at Determinate Systems and has been known to write blog posts and give talks at conferences. He brings a deeply technical expertise, but also strong focus on developer experience. And he has a knack for making complex topics really understandable. So I'm excited to have him leading this presentation today. Luke is one of the developers of FlakeHub, so he's not only leading our webinar, he's helped build a lot of the technology that we're going to be talking about today. And in just a minute, he's going to give us an overview on how to make Nix deployments seamless with all the features that we have built and some of them that we've pioneered for FlakeHub. So before I turn it over to him, just a couple of housekeeping things. We will do a Q&A as part of the session. We encourage you to drop your questions as they come to mind during the webinar or at the end, whatever works best for you. But use the Q&A feature that you'll see in Zoom. We also have chat enabled. When you use chat for the first time, make sure you've selected everybody if you want to send a message to all other people in the webinar. Otherwise, it'll default you to messaging only the hosts or panelists. And then know that at the end of this, we will send out a link to the recording. We'll put it up on our YouTube. We'll send it out to you here if you want to be able to rewatch it, revisit something, or share it with a colleague. So that's it. Let's get on to the interesting stuff. And Luke, I'm going to hand it over to you to talk to us about seamless Nix deployments with FlakeHub.
Okay, sounds great. Thanks a lot, Jeff, for another great intro. Hello, everyone. This is Luke here. I am speaking to you from Buenos Aires, Argentina, the greatest city on the planet, if you ask me. It really is nice to be back with another webinar, talking to people about Nix and Determinate, spreading the good word. And I'm not just saying that perfunctorily. I actually do have a lot of fun being out there in the public and in the community and talking to people. Last time I talked very specifically about FlakeHub Cache and how I think it can quietly but profoundly transform your daily workflows. This time around, I'm going to take a somewhat broader perspective to talk about deployments with FlakeHub. And I always enjoy talking about deployment because that's kind of the whole point of all of this. Development environments and build processes and caching and all this stuff is fun and great, but none of it really matters if you're not ultimately running stuff, providing real value in the world. And that's going to be the general perspective of the talk today. So what the heck is deployment? Well, I think it boils down to two basic stages. First, you need to build and package some runnable software artifact. That's typically some kind of server that accepts traffic and performs a set of tasks, just to provide a very high-level generic definition. And that runnable artifact itself is generally either a virtual machine that can be spun up by a hypervisor inside of a data center, or something like an OCI container image that can be run using Kubernetes or Fly or some other container orchestrator. But it could also be, say, a WebAssembly binary or a serverless function or some other thing that's way ahead of the current technological curve. Today, we're just going to stick to some more traditional artifacts because Nix could do fun stuff in this domain, but it remains a little bit exotic. So once you have a desired artifact, you want to run it on some chosen platform. So that could be a virtual machine on Amazon EC2 or a container image on Google Container Engine, amongst many other examples. Now, there are tons of deployment of models available, and there are whole industries or whole sub-industries and conferences devoted to that question. But I want to highlight and discuss two very general models today. In the first model, you treat deployments like pets. So you have some limited set of machines that you manage, and you update those machines in place whenever you need to run something different. The Nix community, I think, has mostly opted for this model historically, although I do think that this could potentially change over time. In the second model, you treat deployments like cattle. So you have some indefinite number of machines that you're constantly creating and destroying. If you need to update a deployment, sure thing. Build a new artifact, kill the old one, run the new one. And you do that for every change you make to your production setup, no matter how minor. Now, like I said, the Nix community has generally not opted for this model, but again, I think that could change. Other communities, on the other hand, generally have opted for this model, such as the so-called cloud native paradigm. And personally, I hope that the Nix community eventually does as well, and I'd love it if Determinate could play some small role in that. I want to say something briefly about how Nix can play a transformative role in deployment. So first, Nix has all these amazing built-in capabilities that make building artifacts a dream. And of course, I suspect that a lot of these are going to be familiar to people. So you get reproducibility, you get sandbox builds, you get an actual programming language that you can use to describe your builds and all of that fun stuff. But you also get what are called runtime closures, which essentially means that Nix can build not just the thing that's running, like your server or process or whatever, but also all the stuff that the running thing needs to have available to work properly at runtime. And Nix can package up that entire closure into, for example, a NixOS closure or a container or some other artifact. And things that aren't Nix generally struggle with runtime closures because, if you're using shell scripts or Docker files, you can provide runtime dependencies, but the difference is that it kind of works by accident, but Nix fundamentally works this way. Like Nix doesn't work in any other way. And I think that that's a very powerful thing. Finally, one thing that I like about Nix when it comes to deployment pipelines is that flake references, well, Nix if you're using flakes, which of course we support, is that flake references enable you to build anything from anywhere. And that gives you a lot of flexibility in constructing deployment pipelines. So unlike shell scripts and Docker files and such, in Nix, it's really easy to expose and share build logic across your different processes and platforms. I could name plenty of other things about Nix that make it great for deployment, but those seem like the most salient to me for our purposes today. Now let's talk about pets first, specifically working with NixOS systems as pets. So NixOS is absolutely fantastic as a pet. I would say even transformative. And when people talk about the benefits of using Nix in general, the bona fides of NixOS are nearly always part of that conversation. So NixOS is great as a pet, first for the same reasons that we love Nix. So you get fully reproducible system builds, at least if you're using flakes, whisper. You get caching, you get Nix's tooling, you get the Nix ecosystem, and all of that good stuff. But another crucial thing that NixOS offers is what are called atomic updates, which is where when you update your system, the update either completely succeeds or completely fails. If it completely succeeds, then you're now running an atomically different system. What never happens is that an update partially succeeds and leaves messy little inscrutable bits of state all over your file system. And this non-atomic update problem has always been the bane of older tools like Chef and Puppet and Ansible. Okay, so you're currently running a specific NixOS system, and on that system, you make some changes to your configuration, and now you can run this magical NixOS rebuild switch command, which builds the system and creates a new, what's called the generation. And because you have atomic generations, that means that you can potentially roll back to previous generation if you don't like the current generation. And this, once again, puts NixOS light years ahead of systems that deal with messy state transitions using scripts and changes to your root file system. So the general workflow for NixOS as a pet system on the deployment side goes something like this. So first, you create a NixOS configuration and turn it into a virtual machine that works on some platform. Then you deploy that virtual machine to the target platform. And anytime your configuration changes, like when you fix a bug or add some new functionality, you update the existing virtual machine in place. And you do that as long as you need to. And that might mean making hundreds of changes across several years. Now, it sounds far-fetched that you would do this, but I actually know some NixOS folks with pets that are like literally teenagers now. They're 10 years old, 15 years old. There are probably some NixOS systems that are 20 years old running in production somewhere today. So let's talk about how people have typically done NixOS deployments as pets in the past. So for the sake of example here and elsewhere in this talk, I'm going to be talking about deployments to AWS EC2, but I think that what I'm talking about is applicable much more broadly. So first you write up a configuration.nix file that defines your NixOS system, your file systems, device drivers, shell utilities, the server process you want to run, your runtime closure, all that good stuff. And maybe you run it locally using QEMU or some kind of virtualization, or maybe you just have a dedicated desktop system and you boot that thing up using a USB with your desired system on it. And it sounds janky, but there are some people in the Nix world who do this, trust me. So you have the NixOS system that you want, then you build it into something that you can run on AWS. So you create an Amazon machine image or AMI for it. There's this great community tool called NixOS generators that enables you to do this pretty easily. So you run a command like this, you specify the output format, and then you point to your configuration file. And then you end up with a .img file that contains your fully built AMI. Then you upload the image to S3, making sure that you get the directory name and the file name right. Then you import the snapshot from S3 into EC2. Then you register the image with EC2. And then finally, with your image registered and hopefully ready to go, you can start it up using a run instance command from your AWS CLI tool. Now, at this point, your instance should be up and running. Great, and hopefully performing its intended task and making you extremely rich. But life is full of changes, and at some point you need to update your service. So maybe you fixed a bug, maybe you've added a spicy new feature, and some spicy feature that'll make you even more fabulously rich. Now, in order to do that, you need to update your system configuration. So maybe just updating the package for the server you wrote in Python or JS or Java or whatever, and then push that new configuration to GitHub. So with the new configuration exposed by your Flake, you can use AWS Systems Manager to tell your running instance to update itself. So here we see an example command that tells the instance, hey, run NixOS rebuild to update yourself. And so after some number of minutes, that's been successful, and the new state of the system is operative. This works, and it's a well-understood process, but as a kind of baseline community standard of what we expect, it's not awesome, and we at Determinate Systems have never loved this model. And of course, as you can guess from the big red X mark in the title of the slide, there are some problems with what I'm calling the old approach. So first, it's a lot of steps. So anytime you have some new base NixOS configuration that you want to deploy, you need to upload, import, register, and start like we did in the previous slide. Another problem is the evaluation plus fetching time. Now, typically, NixOS rebuild would be talking to a cache and pulling everything from there. But in order to do that, the instance would need to be configured to do that. So you need to perform some kind of secrets injection to ensure that your instance can pull from your cache. And secrets management is always something you want to avoid if at all possible. Then there's the related issue that when you run NixOS rebuild, Nix needs to calculate the store path of your NixOS system closure, and that can consume a lot of resources. It can consume tons of memory, and it can take several minutes. And of course, minutes is a lot in the world of deployment. Now, so this perhaps isn't a huge issue on a big beefy EC2 instance, but on less expensive instances or resource constrained devices, this can be a major hindrance. And this is especially problematic when you're running in places like auto scaling groups, where instant startup time and startup coordination is really essential, and where you don't want some instances lagging behind the others. And finally, there's the issue that the old approach is fundamentally geared towards code being public. So NixOS rebuild has no issues talking to a public GitHub repo to access the Nix expressions that it needs to work. But if you want your code to be private, and I imagine most of you, oops, sorry, where did we go? Oh, wait, no, where are we here? Oh, right here, there we go. But if you want your code to be private, and I imagine most of you would prefer that, then authentication becomes a real challenge because you need to enable your EC2 instance to access private GitHub repos. And that's another setup step involving secrets and SSH that you'd rather avoid. So we talked about the ungreat way to do NixOS as pets on AWS. Now we're going to talk about the better way, and that, unsurprisingly, and for the DETSYS webinar, means doing it the Determinate way. So to facilitate qualitatively better NixOS deployments on AWS, we published our own base AMIs. You can check those out on the GitHub repo at Determinate Systems/NixOS AMIs. Now, our AMIs come with two important things installed. So first, they come with Determinate Nix. So Determinate Nix is our downstream distribution of Nix. It's essentially plain old Nix, but with flakes considered stable by default, plus some other goodies. So for example, Determinate Nix includes Determinate Nix-D, which is a kind of general utility that makes Nix work seamlessly with FlakeHub, our Flake platform, and also performs some other tasks like automated garbage collection. The AMIs also come with FH, which is the CLI tool for FlakeHub, and that has some uses that we'll see in just a moment here. It's also important to note that these AMIs are built, like I said, for seamless authentication with FlakeHub. So there's no static key pairs, no secrets management, or anything like that. They're built to use AWS's simple token service, or STS, to authenticate automatically. And in order to make that happen, you need to first create an AIM role for any instance running one of our AMIs. And then you need to register the ARN for that role in our UI. So it's just a simple copy, paste, and click. And now any instance that has that role can talk to FlakeHub Cache and pull from private flakes, no problem. And you'll basically never think about it again. So you're not copying any public-private key pairs. You're not doing any secrets management or anything of the sort, because the information that AWS provides to us is enough for us to make that authentication determination. So with all that in place, you can apply a specific NixOS configuration on your instance using just two commands. So first, you can run Determinate Nix-D login AWS, and that performs the whole authentication dance. And then you can run FH apply NixOS. So this is a special command in the CLI tool, and provide a FlakeHub flake reference for the configuration you want to apply. And then a semi-magical thing happens. And that magical thing is that FH pulls the entire NixOS system closure directly from FlakeHub Cache without having to build anything locally. And essentially what it does is it basically just uses Nix as a kind of fancy rsync that just fetches raw bytes and puts them in the instance's Nix store and starts the instance back up. And not only that, but it does all of this without even needing to evaluate the store path for the closure, which, as I said before, can be a slow and resource-intensive operation. And reducing the time it takes to spin up a system to an absolute minimum means that running NixOS in, like I said, in places like auto-scaling groups and in other time and coordination-sensitive ways and environments becomes viable. And it becomes attractive in a way that it hasn't been historically in the Nix community. Now, in order to actually apply this configuration, there's a few things you need to do. So first, you need to create a flake that outputs your NixOS configuration, and you need to publish that to FlakeHub. Because when you publish to FlakeHub, that means your flake can be private, and you can take advantage of all the authentication primitives that we provide. So these are primitives that GitHub itself doesn't and will not ever provide. You also need to build and cache your configuration. And a really straightforward way to do that is to use our determinate system /CI workflow, which you can check out on GitHub. And that works automatically, and that workflow automatically builds and caches all of your flake outputs with just a few lines of YAML. So it does a kind of auto detection thing where it looks at your flake, sees all of the outputs that are derivations, and it builds them, and it automatically pushes all of those derivations to the cache, and of course the entire closure for all those derivations as well, because that's just how Nix works. Next, you need to assemble an EC2 instance using whichever tool you use for that. So that could be Terraform or Ansible or NixOps or something else. And of course, we hope that you're using some kind of infrastructure as code tool, but we're completely agnostic toward what that is. And all you need to do there is to use the determinate Nix AMI as the base image, and then provide the custom script from before. So the login step and the apply step. And so you start up your instance, or perhaps many of them in an auto-scaling group, or perhaps in many different groups. They need a few seconds to do their thing, and you're off to the races. So what happens when you need to update your configuration? You've added an amazing new feature, or you fix some grievously devastating bug, and now you're ready to move on. This part of the flow is just like the last one. So you can use AWS SSM or AWS Systems Manager to send a message to your running instance telling it to update itself. But this time, you just need to send it this fhapply nixOS command because it's already logged in and ready to go. Now, for the flake ref that you're updating here, you have a few options here in terms of which version of the NixOS configuration to pull. And this is where FlakeHub's semantic versioning for flakes enters the picture. So you can pull a specific version of your configuration, say 1.2.3, or you can pull the most recent within some version constraint. So if you specify 1, then that will pull the most recent 1 dot something, but it won't pull 2 dot something, and it won't pull 0 dot something. Or you can just pull whatever the most recent version is by specifying star. And this flexibility is great because it means that you can have meaningfully versioned services. Most orgs, I think, don't usually do this. They just kind of run latest because they don't really operate within a paradigm that allows them to think about service versioning in this way. But with FlakeHub, you can, and this is all just baked in. So everything is sitting in the cache. All the store paths have already been resolved. Everything is just ready to be fetched and to have bytes pulled over the wire. And the determinate Nix AMIs are sort of different from other setups because they're really just these bare minimum vessels for fetching bytes and putting them to work. And that's very different from building your own AMIs over and over and over and over again. So we've talked about pets. Now let's talk about cattle. So like I said, NixOS has cattle. And by that, I mean, NixOS where you're just constantly building new VMs, like every time you make a change, and spinning down old ones and spinning up new ones and rotating the way that you would in Kubernetes or something like that. This hasn't really been the Nix community's paradigm, but some people have done this, and I'll tell you generally how they have done this. So the basic workflow here is just like with pets. So you create your configuration in the configuration.nix file. You build this configuration into an AMI. You upload the image file to S3. You import a snapshot from S3 into EC2. You register the image with EC2. And finally, with your instance registered, you can run it. This is all just like the last time so far. The crucial difference here is that when you update your configuration, you repeat all the steps above and you build and run a brand new instance. And maybe you just forget that the last instance even existed. Maybe you even delete it from your AMI registry. And because you're always building and deploying things anew, you don't perform any kind of rebuild because you consider the current system final and immutable. Well, out with the old, in with the new. Let's talk about how Determinate changes this. Well, it turns out that doing NixOS systems as cattle with Determinate is a lot like doing it the pets way, where you use the determinate Nix AMI as a base, and where you modify the user data like before, you modify the user data to log into AWS and then fetch and apply a system closure upon startup. The core difference here is that unlike the standard approach to NixOS's cattle, unlike the standard approach to NixOS's cattle, you're not building a ton of your own AMIs. You're just using ours, and you're changing the startup script. And that means that you're not managing an ever-growing catalog of AMIs with their own name and tag systems. The only piece of information that varies across these cattle is the flake reference for the NixOS configuration being applied. And so that means that the pets and cattle workflows essentially converge into one thing. It's all just our base AMI with some variation of the same startup script. So you can start with a pets approach and move towards a cattle approach later on, or vice versa, and mix and match. If you'd like to see a full-fledged example of this, I recommend checking out our demo repo just at Determinate on GitHub at Determinate Systems/demo. And what this demo does is it uses Terraform to run EC2 instances in exactly the way that I've described here. So there's lots of really great copy and pastable bits that we've actually used internally on many occasions. It ties together Terraform and SSM and our Determinate Nix AMIs and all this stuff into a single coherent package. It's really great. So briefly, I want to mention some other deployment things you can do with the Determinate platform, because we also have some built-in support for both Home Manager and Nix-Darwin. First, Home Manager. So if you aren't familiar, this is a Nix-based tool for configuring home environments. So this is things like dot files, shell configurations, IDEs like VS Code, and many other things. And it works on both Linux and Mac OS. And our platform has some fun stuff for Home Manager users. First off, you can check it out on GitHub if you're not familiar. I strongly recommend it as an alternative to Homebrew and a lot of other ways of doing this circulating out there in the community. I've spent literally like dozens of hours of my life tweaking my Home Manager configurations. And trust me, once you go down this road, there's absolutely no turning back, I assure you. So remember FH, the FlakeHub CLI that we used to apply things before. Well, it also supports applying Home Manager configurations to the current host the same way that it applies NixOS configurations. So you can run an FH apply Home Manager command like this, specify the proper flake reference for the configuration, which of course, everything is published to FlakeHub and cached in FlakeHub Cache, and it fetches the whole closure for your Home Manager configuration directly from FlakeHub Cache. So the first thing you need to do is just publish your flake to FlakeHub with a home configurations flake output that contains your configuration. So you can essentially publish and cache your entire Home Manager closure and then pull it directly from FlakeHub Cache the same way that you pull a NixOS system directly from the cache. For macOS users, the same things goes for Nix-Darwin. So Nix-Darwin is essentially a variant of Home Manager that's tailored towards macOS systems. And Nix-Darwin is quite powerful, and in fact, you can even embed a Home Manager configuration inside a Nix-Darwin configuration, which is what I do. So for going back to FH, you can use FH apply Nix-Darwin to do exactly the same thing, where you pull your entire Nix-Darwin closure directly from FlakeHub Cache, and it's all authenticated. It could be in a private flake, and it doesn't need to perform any store path resolution. Again, to do that, all you need to do is publish a flake that outputs a Nix-Darwin configuration, push that to FlakeHub Cache, and you're good to go. So when would you actually do something like this? I mean, most of us use Home Manager Nix-Darwin on our personal workstations, and this seems like maybe a bit more fanfare than necessary just to manage our personal stuff on some platform over there. Well, I think that even for personal configuration, this can be nice for things like getting a new laptop up and running to our exact specifications. And I got my laptop stolen in December, and I ran FH, and I bought a new one like the next day because I had work to do, and I ran FH apply Home Manager on that, and ran some setup steps, ran FH apply Home Manager once I was authenticated, and that got my new system up and going in like maybe 60 to 90 seconds. And so that's really how powerful this approach can be. I think it can also be good if you use things like ephemeral cloud VMs as development environments, which I often do when I need, I'm full-time Mac OS, but sometimes I jump into a cloud VM because I want to do NixOS, I want to do Linux things, and the ability to apply my configuration there within where all I'm doing is fetching that closure directly as bytes is quite powerful. So again, you can basically run a few commands and apply a configuration, hold rsync style straight from the cache, and you're off to the races. And that's with all your dot files and your packages, your fancy Zeesh or startup or like whatever shell environment you happen to have. My setup is very specific and tailored towards me personally, and I love having that wherever I go. Another potential use case that we haven't seen yet at Determinate Systems, but we're hoping to see in the future, is Home Manager nix-darwin used at the organizational level. So you could imagine publishing a kind of base configuration for the workstations in your company on FlakeHub, and then having those configurations pulled and applied as part of a setup script. So let's say you want to ensure that all of your employees have some set of packages, or you want some default system configuration in place. Well, you can actually do that deterministically with Nix, and you can then terraform your systems en masse using an approach like this. And if this sounds like an interesting prospect to you, please talk to us, because this is something we're very interested in. And we'd love to see a company take the plunge and try to do this. So we talked about NixOS and other configuration systems, which, and these systems are extremely popular amongst Nix folks, but let's face it, not all of us get to use and deploy fun stuff like NixOS VMs and Home Manager configurations. Some of us need to do things like deploy container images and write scripts that unwrap tarballs and copy the contents around. Well, fortunately, FlakeHub has a story for this as well. So here enters another command for FH, the FlakeHub CLI, and that is FH fetch. Here you can see an example of fetching a Nix package and depositing it in the local directory under this package, which is essentially a symlink to something in the Nix store, the same way that result is a symlink to a Nix build operation. So this command is like FH apply in the sense that it pulls bytes directly from FlakeHub Cache, again, without needing to evaluate a store path. And so again, it's basically using Nix as a fancy rsync that just pulls bytes. Now, FH has a lot of potential use cases. You can use it to pull tarballs and zip files and whatever archives you've happened to package using Nix. So maybe you want to pull down an entire NixOS system image. Maybe you want to package up Apache Kafka as a zip file and then unwrap it somewhere inside of some kind of deployment script. You can also fetch things like CLI tools and other utilities. So maybe you want to apply a base NixOS configuration on your EC2 instance, and then you want to fetch a couple other utilities to go with it. And finally, you can use it for container images. So you build an image with Nix and push it to the cache, and then you can fetch it directly. So this is useful if you're, for example, deploying containers to Kubernetes or a system like that. You can build those images with Nix, and then you can fetch them directly from FlakeHub Cache without ever needing a container registry. So you can easily imagine your standard cloud native deployment workflow, but with several steps removed. And that's it. Thank you so much for coming. If you have any questions or any further curiosity, please do stick around for the question and answer session. At any time, feel free to reach out to us at hello@determinate.systems. Come talk to us on Discord at determinate.systems/Discord. And if you're game for another webinar, we're going to be doing another one in a few weeks on using Determinate. We're going to be doing another one in a few weeks. I think we're going to do one specifically on Determinate Nix, which I mentioned a little bit today, but we have some other ideas. So yeah, stay tuned, and we'll let you know soon.
Awesome, Luke. That was fantastic. Thank you so much. You up for some questions? We got a couple coming in.
Sweet. Yeah.
All right.
Lay it on me.
All right. So here's the first one. It says, is FH apply extensible? i.e., what if I want to deploy to some targets other than Home Manager or NixOS?
Yeah, so I'll let you in on a dirty secret, which is FH apply is just a wrapper around Nix itself. So if you want to pull Nix stuff directly from a cache without even trying to build, so basically what FH apply does is it makes an HTTP call to FlakeHub to ask what the store path for something is, because we store those store paths in our database. That's why you don't have to evaluate them. And then it tells Nix, hey, pull pull this store path from the cache, and it does all the necessary wrapping to make sure it's properly authenticated. And it sets a setting called max jobs to 0. And if you set max jobs to 0, that means Nix doesn't even try to build it. It just assumes that it's pulling straight from the cache. So so because it's just a fancy wrapper around Nix itself, in principle, you can apply this approach to any kind of situation. So to other systems, to other types of closures and deployable artifacts. And I would recommend you can see at github.com/determinate-system/fh. You can see the code for that, and you can see in there the command wrappers around Nix. And hopefully here I'll just put a link here, and hopefully that would be enough for you to kind of like reverse engineer that. But if not, please do feel free to ask us on Discourse or some other place, and I can point you to much more specific code references for that.
All right, cool.
Because I did write I did write that, so or I helped to write that, so I can point you to very specific places.
You've helped to write just about everything at Determinate Systems. Here's another question about FH Apply and FlakeHub. Can I use FlakeHub plus FH Apply to baseline employee max over MDM? And I think MDM here would be mobile device management. I think the answer is yes, because I know we did a Jamf integration recently, but do you have any more you want to share on that, Luke?
Yeah, for MDM, I'm not. So in principle, yes. If your MDM setup included authentication, so I'm not sure. I think that would be the only missing piece to me, is because we do support MDM. We do support MDM for getting Nix installed, especially for installing specifically for Determinate Nix. And if your MDM script had some way of authenticating with FlakeHub, and this is the question mark for me, and if somebody wants to jump in from DetSys and tell me how this would be possible, then yes, then you could, for inside your MDM script, you could say install Nix, authenticate with FlakeHub, and just FH apply home manager this flake reference, or FH apply nix-darwin this flake reference, and that would presumably just work.
Yeah. And I'm actually working with two customers right now that this is the core use case. So if this is for the person that asked this or anyone else, if it's something you're interested in, let us know and we can work with you to make it happen, because it is being done today. Here's another one. This is a little bit more about Determinate Nix. And the question, I'm going to kind of summarize it a bit. The question is basically, is there much of a difference between upstream Nix and Determinate Nix? And then it goes on to ask about, can they still use stable, unstable channels for upstream Nix? And how would they get started with Determinate Nix and bootstrapping a config?
Yeah, so I would say for, right now that there isn't a huge difference between Determinate Nix and upstream Nix. There are a couple of Determinate Nix is currently more flake oriented. So you don't have to set experimental features, Nix command flakes anymore. That's already essentially built in. It's also built to interoperate with this Determinate Nix-D tool, which is quite nice. But in general, yeah, I mean, a lot of the stuff that I've discussed today would potentially, in principle, work okay with upstream versions. But again, when it comes to once you start trying to interoperate with FlakeHub Cache, once you start trying to use some of these other features, they do, they have been kind of built as a coherent whole. And so there are limits to the kind of guarantees that we can make for using other variants of Nix, like upstream variants. And Jeff, what was the second part of that question again?
How can I get started with Determinate Nix and bootstrapping a config?
Yeah, so I would say if you want to get started with Determinate Nix, I just put a link there, docs.determinate.systems. So right there on the front page, there's going to be an installation widget, and you can click on Mac OS. There's a graphical installer that just like downloads a .pkg and walks you through that. I think on Mac OS, that's definitely the preferred way. If you're on Linux, which includes WSL or Windows subsystem for Linux, there's like a curl to bash command that uses our Nix installer, and that's generally the best way to get started.
And I'll add that there's nothing special that needs to be done to bootstrap a config. Determinate Nix is Nix, and the core difference today is that flakes are on by default because we believe in the power of flakes, and we have our own daemon determinate Nix D that does a lot of automation for you, and we have a whole bunch of enterprise features coming down the pipe, all things that we are PRing upstream. But if they don't get merged quickly upstream, then they'll be available more quickly in Determinate Nix. So Determinate Nix is Nix. Um, w- Two more questions maybe here. Next question is, in a poll model with FH apply to keep machines up to date, would you trigger that from a cron or system D timer? And then the follow on is there already some NixOS module that takes care of that?
Yeah, in principle, you certainly could. So you could potentially in your user data, or I'm sure that Terraform and other tools enable you to apply cron logic to an EC2 instance fairly easily. Yeah, I don't. There's absolutely no reason why you couldn't. And one of the nice things about semantic versioning, for example, is that like I said, so one of the things you can do is you can pull a specific version, version 1.2.3 of your NixOS configuration. But if you apply a more loose version, so let's say every 24 hours you want to look at the version 1 series of NixOS configurations, and FlakeHub will be able to tell you like, nope, nothing new, nope, nothing new, nope, nothing new. Okay, a new configuration. We were bumped from 1.2.3 to 1.2.4 and have that auto apply. That is 100% possible, and I think a pretty mainstream use case for FH apply.
Got it. All right. Okay, I'm going to do one more question and then I think we'll wrap it up here. This last question is related to using ECS. And it says, for a company that heavily uses ECS, if they were to adopt Determinate Nix for deployments, are there docs available or other kind of proven workflows that they can reference?
Yeah, I actually let me pull up a repo for you. So I did a talk, um, Nix to. So I did a talk a while back about Nix and Kubernetes. I don't necessarily. So I just pasted a repo here. I don't necessarily endorse this as like a super up-to-date way of doing things, but this does show an example of building container images using Nix, and then deploying them to using standard kubectl deployment workflow and doing things that way. I would say that like I said, nowadays you could potentially do this all in CI just with using Nix, or you could also, like I pointed out FH fetch before, where you could have some system whereby you're building container images using Nix in CI, and those are going up to FlakeHub Cache. And then in some other workflow, maybe you're on Terraform Cloud or something like that, you could potentially use FH fetch to pull those images and deploy them, for example. Whatever deployment logic you have, I don't think there's anything really special about ECS here, because it's just as far as I know, it's just I think it's either Kubernetes or like Kubernetes adjacent. So I wouldn't say that I necessarily have any specific like proven workflows, but that repo I think does give you a kind of general sense of what that may look like.
Cool. All right. So there's a link in the chat. And then, for both the person that asked this question, anyone else, feel free to shoot us a note to hello@determinate.systems, and we'd be happy to talk with you about more specifics and provide any more specific advice if it's needed. So, with that, I'm going to wrap things up for today. We thank you so much for joining. This has been wonderful. Luke, thank you so much for presenting again and for sharing all of your Nix expertise. This session has been recorded. I should be able to have it up on YouTube in the next 24 hours or so. And once that's ready, I will send out a link to everyone that registered for the webinar. So feel free to rewatch it there, share it with your friends, and keep an eye out for our next webinar. Like Luke said, it's likely going to be on some of the new advancements we've made with Determinate Nix. We have a really exciting roadmap. A lot of it around performance for larger organizations, larger repos, as well as some user experience improvements to make Nix a little bit less frustrating in those few times when it can be frustrating. So keep an eye out for that. Thank you so much. If there's anything we can do for you, hello@determinate.systems or go to determinate.systems and you'll be able to find a link to our community Discord where we talk about Nix in general, but we also have channels about our products if you need any support there. So thanks again, everyone. Have a fabulous rest of your week and do more of what makes you happy.